Hello everyone. In this session, we are going to talk about the DAX advanced features. So we have already seen what is DAX and what can we do with it. DAX is a powerful formula language in Power BI, which is data analysis expression that allows the users to create sophisticated calculations and data models. While DAX is often used for basic calculations, it also offers the advanced features that enables more complex data analysis and modeling. These advanced features are essential for the users who want to leverage the full power of the Power BI for in-depth analysis. The first one is the advanced calculation with variables. One of the advanced features in the DAX is the use of variables. Variables allows you to store the result of an expression and reuse it into your calculations. This not only improvises the readability of your DAX formulas, but also optimizes the performance by avoiding the repeated calculations of the same expression. Example, you can define a variable to calculate the total sales for a product category and then use the variable to calculate the percentage of total sales that each product contributes within that category. Next one is the context transition and row context. Understanding context transition is crucial when working with the advanced text features. Context transition refers to the process by which row context, which is the context of a specific row in the table, is converted into the filter context, which is the context applied to evaluate the expression into a text formula. This is especially important when using the functions like calculate and filter. For an example over here, in a calculated column, each row has its own row context, but when using calculate, the row context is transformed into a filter context, which affects how the formula is evaluated. The next one is the time intelligence functions. Text includes a robust set of time intelligence functions that enables the advanced database calculations. These functions are particularly useful for analyzing the data over time, such as year to date, quarter to date, and month to date calculations, as well as performing the comparisons between different time periods. For an example, you can see the use of the dates YTD function to calculate the cumulative sales up to a certain date within that current year. The next one is the iterative function. DAX provides iterative functions like SumX, AverageX, and RankX, which allows you to perform row by row calculation across a table. These functions are used when you need to perform the calculations that depends on the result of each individual row rather than on a simple aggregation. For an example, RankX can be used to rank the products based on their sales, taking into the account the entire dataset or a specific subset of the data. The next one is the parent-child relationships or parent-child hierarchies. DEX supports the creation of parent-child hierarchies, which are common in organization structure, product categories, or any other hierarchical categories. These hierarchies allow you to perform the advanced analysis within the nested structure. For an example, you can create a hierarchy in an organizational chart to analyze the sales performance by department, team, and individual employee. The next one is the advanced filtering techniques. DEX provides advanced filtering capabilities, allowing you to create more complex filter conditions into your calculations. Functions like filter, all, all except, and remove filters give you fine grained control over which data is included in your calculation. For an example, use filter to include only certain rows in a calculation, such as calculating the average sales amount for the products that have sales greater than a specific threshold. The next one is custom aggregations and dynamic measures. DEX allows for the creation of custom aggregations and dynamic measures that can change based on the user interactions or slices in the reports. This dynamic behavior makes the report more interactive and insightful. For an example, create a dynamic measure that calculates the total sales for the selected product category, changing as the user interacts with the report. The next one is the complex calculated tables. In addition to the calculated columns and measures, DEX allows for the creation of calculated tables, which are tables generated by the DEX formulas. These tables can be used for advanced modeling scenarios, such as creating a table that only includes specific data or generating a summary table. For an example, create a calculated table that shows only the top 10 products by sales. The next one is the performance optimization techniques. As you created more complex text formulas, performance can become an issue. DEX provides various optimization techniques such as using the variables to avoid the repeated calculations, minimizing the use of nested functions, and leveraging the built-in functions that are optimized for performance. Over here, in example, you can use the variables to store intermediate results and reduce the number of calculations performed. So to conclude, advanced text features empowers the Power BI users to create highly customized and efficient data models. By leveraging these features, you can perform complex calculations, optimize performance, and create the dynamic and interactive reports that provides the deeper insights into your data. Whether you are dealing with time intelligence, hierarchical data, or the need for customizing aggregations, mastering the advanced DAX is the key to unlocking of the full potential of Power BI. Thank you.